Hello, everyone. I hope you guys are having an awesome day so far. For today, we are going to learn some quantum numbers. Okay, now there are four quantum numbers that we're going to focus on today. Uh, and from those quantum numbers, we should be able to determine the different elements. Okay, we should be able to figure out, the different elements based on the four quantum numbers. Okay. So if you have to pause the video at any point, you can. That would be a great idea. Um, so let us try some of these out. I'm going to present my screen here shortly. Okay, hopefully you can see this piece of paper. All right. So the first quantum number we're going to focus on here is the principal quantum number. Okay, the principal quantum number. And we designate the principal quantum number as the symbol n. Okay, so what the n means is the energy level it's in. Okay, and the energy level means, like, for example, if we have this paper, okay, the energy level is basically 3, 4, over here, 4. That's the energy level. All right, so n can go up to 7. 7's the largest number it can be on the periodic table. Okay. All right. After the energy, we have, or principal quantum number, we have the angular momentum quantum number. And we designate this to be a cursive L. Okay. Now, L relates to many different things. All right. So if the L is equal to 0, that means you have an S. If L is equal to 1, that means you have a P. If L is equal to 2, that means you have a D. And if L is equal to 3, that means it is in the F column. S, P, D, and F, that mainly just represents where it's at. S, D, over on the right, you got P, and at the far bottom, you have the two Fs. So that's the angular momentum number. Okay. After the angular momentum number, we have the magnetic quantum number. Okay. The magnetic quantum, let me bring it up in a little bit, quantum number. Okay. We designate this by ML with the little L. All right. So for any S, we draw one box, one orbital, and hopefully we learned that the last couple days. For any P, we draw 3 boxes. For any D, we draw 5 boxes. And for any F, we draw 7. 1, 2, 3. Okay. And when we have these boxes, the middle number is always 0, 0, 0, 0. And then you just count 1. That's going to be -1, -1, -2, 1, 2, a 1, 2, 3, -1, -2, -3. Now, these numbers represent the ML. So the ML means which box was the last arrow drawn. Which box was last arrow drawn? Okay. And the last one I would like to discuss Hold on. Is the spin. Okay, last one is the spin quantum number. And the spin quantum number, if your last arrow is up, that means it's positive 1/2. If the last arrow is down, that means the spin quantum number is negative 1/2. Okay, so what we're going to do is we're going to apply all this information. We're going to apply all this information and try to solve some problems. Okay, so what I'm going to do is I'm going to pick a random element, maybe like, let's do hydrogen. Hydrogen's number 1, so it's up here. Okay, so hydrogen is 1s1. So if I'm drawing the boxes, there's my 1s and 1. So my first person to walk on the bus has an up arrow. So let's walk through the 4 quantum numbers. All right, so n, well, I'm in 1, 1s. So my n is 1. S represents, well, my L is going to be 0. All right. Well, my magnetic quantum number can only be one thing. There's only one option for S. So my ML is going to be 0. And then was my arrow up or down? Well, we designate this to be MS. My MS is up, so it's positive 1/2. And those are the 4 quantum numbers. Okay. Now I'm going to do another one. Let's do oxygen. Oxygen is located right here at 2p4. All right, if you want to pause the video, you can do so. But I'm going to keep moving. So the N is right there. It's 2. All right, the L, well, what does P represent? P represents, let me scroll down a little bit. What's my L? L is 1 at P, so L is 1. My ML, well, I got to draw my boxes out. So I got to draw 4 arrows because it's 2p4. So there's my first guy gets on the bus, second guy gets on the bus, third guy gets on the bus. Fourth guy has to double up. He's going to be sad about it. So I drew my last one in that box. All right, so it's in my first box. My first box has a number of -1. And my spin was my last arrow up or down. My last arrow was actually down, so it's -1/2. Okay. So I want you to try 2 problems out, all right? I'm not collecting this, but I want you to write the magnetic numbers for titanium. And I want you to write the magnetic number for neon. Okay, I want you to try 2 of those out. I will go over more examples tomorrow, so we can get a better hang of this. And give some more example problems, okay? I'm just introducing the data today. So I hope you guys have a great day, and we will see you tomorrow.